In this video, I'm going to be talking all about how you can assign types in TypeScript, which we've already kind of looked at a little bit, and then also the most important part of TypeScript, which is type inference, which is how you can do pretty much everything in TypeScript without actually knowing that much TypeScript. So the very first thing I want to talk about is how you actually assign a type to a variable. We can just come in here, we can create a variable a, and let's just say we're going to set it to 4. And we want to actually type this variable a as a number so that TypeScript knows this is a number and we can only do things related to numbers with it. Well, the way that you do that in TypeScript to type a variable is what you do is you just put a colon after the variable, put a space, and then put whatever the type is going to be. Now you will notice when you type out number, there are two different ways you can do it. One is going to be lowercase number and one is going to be uppercase number. It's the same thing with string, boolean, and a bunch of other different primitive types in JavaScript. The important thing to note is when you're doing things like string, booleans, and numbers, you always want to use the lowercase version instead of the uppercase version. That's because of the way that JavaScript is actually written, because what you can do is I can say I want to create a new number like this, and that will give you a type of uppercase number, or you can just use a normal number like 4 or 3, and that's going to be a lowercase number. Now, it's not important that you know the difference between the two because it's super minute and it's like really hardcore JavaScript stuff that determines those differences, but when you're defining types in TypeScript, just make sure to always use that lowercase primitive version instead of the uppercase version. Now, if we save this and we try to do something on a, you can see we have all the different methods that are available on our numbers. For example, toFixed, toExponent, toString, and so on. If we hover over this a variable, you can see it has a type of number. So we at least know that this is working. You can even see that the way that things are typed when you actually hover over them is that same colon syntax that you can see right here. Now, if I were to create, for example, a string instead, so if I wanted this to be a string, you'll now notice I get an error because I have it explicitly typed as a number, but it is a string. So I'm going to come in here, I'm going to say that this is now a string. Also, something that's really nice about TypeScript, if I try to assign this to a number, I'm going to get an error because I can't assign this to a number since I explicitly declared that it is a string. So this is just some of the power right here behind TypeScript. Whenever you type something as a specific type, it assumes it's always going to be that type, so you can never redefine it as a different type. It's just going to be like, okay, this is a string, you're trying to assign a number, that's obviously not going to work. That's what allows you to get that really good autocomplete and the really good error protection. Now, I also talked about how you can have type inference, which is the really powerful part of TypeScript. And what I can do is I can just remove where this says string and the colon right here, and my code is going to work exactly the same. When I hover over a, you can see it has a type here of string. And you also see down here that I'm still getting an error because I'm trying to assign a number to a type of string. And this is what I really love about TypeScript compared to pretty much any other typed language out there, is that TypeScript is smart enough to just look at your code and know what the different types of things are going to be. So you don't have to write actually that very many types inside of your JavaScript code. Most of the time, the only time you actually need to type something is when you are defining a variable that has no value at all. So for example, here, this doesn't have any type. And if I wanted to give it a type, I could say that it is going to be a string. That's one scenario. Or when you're defining functions, that's another scenario where you have to give things types. But in almost all other scenarios, you can just infer the type of things based on what you assign them to, which is something I really love. Now, one thing that you may have noticed if you're following along with this is that actually, if I just come in here, we're just going to say that this is going to be equal to the value of 4. We'll get rid of this down here. So it's going to be a number. You can see when I hover, it's a number. If I were to use const here instead of let, you'll actually see that the type A here is the explicit value of 4. Now, the reason for this is because of something called a literal type in TypeScript. A literal type just says that this variable or whatever you're typing can only be literally one thing, and that is the value of 4. That's because this is a constant variable set to a value of 4. This can never change. It's impossible for me to say like a equals 3. That fails in JavaScript, not just in TypeScript, but it's going to fail in TypeScript as well because I'm trying to assign 3 to a value that is supposed to be 4. So when you use const to define a variable and you give it like a static primitive value, like a number or a string or something like that, it's going to show up as an actual literal type instead of the more generic number type because this can only have the type of 4. Now, this is different if you use an object, for example, and that's because even if you use const, you can still change the properties of an object. That's just a built-in JavaScript feature. Same thing with arrays, so you don't have to worry about that in those cases. But if you're using primitive values, you will run into that if you use const, which is perfectly okay. If you know that this is a constant variable of the value 4 that never changes, you should use const to define that and let this inference actually say that this is a literal type of 4. You can also explicitly say something is going to be a literal type. So I can come in here and I can actually type this as the value of 4 manually, and you can see I get the exact same typing definition here. But the point of doing this is pretty much non-existent. You would almost never write out your types like this. Instead, you would just use const and let TypeScript do that inference for you. Now, the final kind of basic type assignment that I want to cover in this video is going to be null versus undefined. And if you're used to JavaScript, you know that null and undefined are technically different from one another. And it's the exact same thing in TypeScript. Null and undefined have their own types and they work just like that. So if I were to set this to null, for example, you can see that A has a type of explicitly null because I assigned it to null as the type. And if I were to try to come in here and set this to undefined, I'm going to get an error because null and undefined are different from each other, so I cannot redefine it to undefined. I can make this a little bit more explicit by coming in here, manually typing this as null, and now you can see I'm getting a TypeScript error because undefined is not assignable to null. Same exact thing if I set this to undefined, and I make sure I type this as undefined here, you'll notice that if I try to set it to null, I'm going to get an error. Now, one thing that you will notice if I leave off this type inference, TypeScript doesn't do any type inference when you set something to undefined or null when it's a let variable, because it just assumes this variable doesn't exist. It could literally be anything at all. It's essentially the same thing as if I left it off like this. A is still undefined. So if you don't give it an actual type and you also don't define a default value, TypeScript doesn't know what type to give it. So it just says it can be any type at all. So mostly if you're going to be dealing with something that must be null or undefined, you're probably going to explicitly type it, or most likely you're just going to use a const variable like this. And these differences between null and undefined are actually a really common cause of bugs inside of TypeScript programs because something may be null and you're only checking if it's undefined or vice versa. So just make sure you're aware of that as you're writing your TypeScript code, the differences between null and undefined, and if a variable is one versus the other. That's one thing to keep in mind that you don't really have to worry about as much when you're in JavaScript.